Today we are presenting the title Machine Translation Using Transformer, and I am presenting my part introduction related work. Uh, use I am excited to share that use with share some fascinating insights into the ever evolving landscape of machine translation and the latest work and neural network techniques in the machine translation. We know that intricates and irregularities of human language present considerable challenges for machine translation. This complexity has led to doubt about the feasibility of human translation for such tasks. However, over the years, we have witnessed significant transformation in the field of machine translations. Initially, translation relied on dictionary-based and rule-based methods, but based methods were manually specified. Subsequently, now we have statistical translation model which are great enhanced over the last years. The progression of neural networks and AI has profoundly influenced various scientific domains, including machine translation. Unfortunately, low resource languages spoken by around 20 to 30 million people across the few regions have been largely overlooked by the researchers in the last few years. To address these challenges, researchers have developed innovative approaches such as the model based on transformers that incorporates the vocabulary dictionary method by gathering parallel texts in the desired language and merging them to create a large training dataset. Significant improvements have been achieved. Moving on to neural network training techniques, the computational intensity of training deep neural networks has proposed significant challenges. Normalization has been introduced as a technique to address this issue by adjusting the inputs to each part of the network during training. The adjustment not only accelerate the learning process but also helps prevent overfitting, making the model more robust. However, batch normalization has its limitations, particularly in network that remember information over time, such as RNN. To overcome this, researchers have developed layer normalizations, which calculates normalization statistics separately for each timestamp, uh, thereby stabilizing the behavior of neurons over time in recurrent neural network and significantly speeding up training compared to other methods. Now I am discuss the related work has been carried during these many years in the field of machine translation. Uh, the into the realm of machine translation, neural network training, uh, and the first sign that unexplored territory of Hindi language translation. The Apratim project has been a pioneer endeavor in this domain, developing a translation system tailored specifically for Hindi through the creation of bilingual and morphological dictionary structural transfer rules and grammatical guidelines. Apratim has laid the groundwork for effective translation in Hindi. However, despite these efforts, challenges remain, particularly when it comes to translating longer and more idiosyncratic sentences. Recent explorations by Ahmadi and Mansood have ventured into the realm of neural machine translation for Hindi. By curating parallel data sets and experimenting with various tokenization techniques, they reported achieving bilingual evaluation under study scores using different tokenizers, expanding our view to languages with limited resources, such as Bambara, presents unique difficulties for machine translations. Bambara, a manned languages, lacks sufficient training data and requires extensive pre-processing. Switching gears, let's briefly touch upon Google Translate's capabilities in the context of South Africa's official languages, which, while Google Translate could translate six of South Africa's official languages up to 2019, comparing its performance to research models proves challenge is due to uncertainties about its training data. In the realm of neural network training, batch normalization has been extended to recurrent neural network with separate normalization statistics for each time step, yielding optimal results. Additionally, weight normalization focusing on the L2 norm of incoming weights has shown promise in enhancing neural network performance. Lastly, I want to discuss a technique called path normalized SGD has been explored, altering parameter updates in the network. However, the proposed layer normalization method distinguishes itself by not only tweaking parameters but also fundamentally changing how the entire layer behaves. Now, the dataset part will be Uday Patel.
I am Uday Patel and I'll be explaining about the data set which we have used to make this transformers based model. Krishna, can you open the documentation of this data set?
Yeah, sure.
So we have used this all the data set. The full form of all data set is Asian language tree bank. This data set contains around 20,000 English sentences, and each sentence is translated into these 13 languages and vice versa. Scroll down. So these are the 13 languages which are there in this data set. Now over to Krishna.
Uh, so my name is Krishna, roll number two, name DC 228. I'll be explaining the model architecture of the transformer, which we are using as a pre-trained model for the purpose of machine translation. So till now, all the sequence to sequence model were using the time step as the time step approach, like the LSTM, RNN, GRU, all were using time step approach. But the problem was that while using time step, each token was included during one time step. So it would conclude a lot of time for the entire sentence to get translated. So the new approach was introduced, which was the transformers. The main attention was provided to the attention mechanism in the transformers approach. For this, the paper was the attention is all you need, where the entire transformer architecture, where the main concept behind using the transformers was explained. It is transformer is a simple encoder decoder mechanism in which there are 6 layers, each layer having 2 sublayers in there. And as you can see in the figure, we provide the input embeddings, and then then attention mechanism works, and similarly we do the feed forward in the encoder, and similarly for the decoder also we do the attention mechanism and then the feed forward, and the output is produced using the softmax activation function. Here, the attention mechanism signifies that the attention should be given to the word which are the most important and which would signify the output. Like for machine translation from Hindi to English, some of the words may be like if they come first for English, they would be occurring in last of the Hindi sentence. So that kind of word should be provided more attention. So that is the importance of the attention mechanism in the transformers. So for this reason, transformers are very fast as compared to the regular model which uses time step. And also transformers are using batch normalization as the to do the normalization at each layer. So for the machine translation purpose from English to Hindi and from Hindi to English, we have used the Google's MT5 small model as a pre-trained model, and then we have trained it on the alt dataset as mentioned by my friend Uday. Here is the proposed model architecture. Firstly, firstly from the corpus we have done the tokenization, and then we have splitted it in the test set and train set, and then we have fine-tuned the model by doing 10 epochs of 20 size, and then provided it to the pre-trained model, and then we obtain the results. This way our proposed model works. Here, I would like to mention that we were able to do 10 epochs only because of the limitations of the GPU. Now, I would like my friend Uday to continue with the methodology.
Now
Uday.
let's discuss about methodology part. The very first step is model selection. We have selected the open source MT5 small model, which is trained by Google. It was trained on 10 TB of dataset and it was trained on around 101 languages. The second step of methodology is data preparation. We have used this old dataset and divided it into training and testing parts. The next third step is tokenization. We have used a tokenizer provided by MT5 model, which is specifically designed to handle multilingual text. Next is model training. We have trained a model on our training dataset on multiple epochs and considering Adam optimizer and learning rate equal to 0.005. The last phase is evaluation phase. We have evaluated our model on testing dataset and we got the loss of 1.125. Over to Krishna.
Now, I would like to explain the results that we have obtained. We have obtained a pretty good result according to what we expected. So, now here we have incurred the loss of only average loss of 1.125 for the entire 10 epochs, and and we can show the results here. That is, for the sentence in English, I was looking for a good laptop. It is providing मैं एक अच्छा लैपटॉप खरीदने के कोशिश कर रहा था. And similarly for a Hindi sentence like आप इसमें बहुत महान है. So it is giving English translation as you are so great. So similarly, all of these are all of these results are obtained to us. And also here you can see the loss graph, which shows clearly that on increasing the epochs, the losses are also decreasing. And here we can see that we have got the average loss of 1.125 at the end of 10th epoch. Here also we can see the training and evaluation losses. So for training, we can see that the loss is decreasing. Now I would like to explain from the code that we have written for the same. So firstly we are importing the required datasets and all. So and now this is the Google MT5 small model, which is the pre-trained model as mentioned by Uday. And also for we are using the auto tokenizer, which is from the Google MT5 small model itself. And now these are all the pre-processing steps. And here we have loaded the alt dataset, and now we have splitted the dataset into train and test. Here you can see the how alt dataset looks. It is like for Hindi language, it is the first sentence of the alt dataset. Similarly for all language. Now here for we have done for English and Hindi language only. So we have done the language token mapping as English and Hindi. We can add multiple also. So these are the functions which are defined to for encoding the string and decoding the string for the fine tuning of the model. And here the 10 epochs are defined and the batch size is also defined. Also the optimizer is Adam used and the evaluation of the model as mentioned. Also the test loss. Now this is the code for which for the training, and here you can see we have performed 10 epochs, and this is the graph as mentioned, and this is the training and evaluation loss. And now this is the input and output obtained from the code. So this is it from our side. Thank you so much.